Actually, the reason I brought up this image is to show you another way to create spline. There's another spline tool called Style Spline. It gives us proper Bézier handles so we can shape the curve exactly the way we want. I placed this image here so we can import it into SolidWorks and put the two images side by side. This way we can first draw a regular spline that traces this hand-drawn curve from Photoshop, and then we'll do the same thing with the Style Spline tool, so you can clearly see the difference between the two. Later, you'll also learn how to import an image into SolidWorks and design directly over it. So if we can accurately reproduce this hand-drawn curve using a spline in SolidWorks, it proves that almost any freeform line from an image can be perfectly recreated in SolidWorks, and SolidWorks can handle anything. To give you a clearer understanding of how a Bézier curve actually works, I've prepared a short video that shows the mathematics behind it in action. We'll watch it together so you can see exactly how the control points and handles create the curve. Just a quick note before we play the video. You don't need to worry about the math at all. I'll give you a few simple explanations as we watch, so by the end you'll clearly understand how a Bézier curve is actually created and why the handles work the way they do. Here we go. I play it and talk you through the important parts. Look, at the beginning the video shows 2 points, P0 and P1. Between them there's a point called L0. That moves from P0 toward P1. Then it shows the equation for L0. It has a parameter called T. That goes from 0 to 1. As the parameter T changes from 0 to 1, point L0 moves smoothly from P0 to P1. So this equation now gives us the exact position of L0 at any value of T. That's the moving point we just saw. Next, it adds a third point called P2. Just like before, it creates another moving point, L1, that travels from P1 toward P2 as T goes from 0 to 1. It writes the same kind of equation for L1, again using the parameter T, so L1 moves from P1 to P2. Now it does the exact same thing one level higher. It creates a new point, Q0, that moves from L0 toward L1 as T goes from 0 to 1. So it writes the next equation following exactly the same pattern, again using the parameter T, but this time it combines L0T and L1T to give us Q0T. Here, as we follow the movement of Q0, you can see a curve starting to form. This curve is a Bézier curve, specifically a quadratic, degree 2, Bézier curve. So, a degree 1, or linear, Bézier curve is just a straight line. A degree 2, quadratic, Bézier curve uses 3 points, 2 endpoints and 1 control point, and produces a smooth curve exactly like the one we just saw. It substitutes L0T and L1T back in, does a bit of algebra, and out comes the classic quadratic Bézier equation. Next, it adds another point called P3. And just like before, it adds a new point L2 that moves from P2 to P3, and writes the same kind of equation for L2T. Then, it adds another point called Q1, and writes the same kind of equation for Q1T. It connects Q0 and Q1. It writes the equation for C0, the point that moves between them. Then, it substitutes Q0 and Q1 and follows C0. You can see C0 now traces a smooth curve. That gives us a third-degree, cubic, Bézier curve, shaped exactly like this. A cubic Bézier can change direction twice. It has up to 2 inflection points. So if we want 2 changes in curvature or 2 inflection points, we have to use at least a cubic, degree 3, Bézier curve. And a cubic Bézier always needs 4 control points. So you can never create 2 changes in curvature with a linear or quadratic Bézier. You need a cubic, or degree 3, curve for that. I hope that's all clear. Let's jump back into SolidWorks and see how these same concepts work with the spline tools. I enter a sketch on the front plane, and this time, I select Style Spline from the Spline dropdown. I leave the spline type set to Bézier. And just like the video we just watched, our spline works exactly the same way. Here we have a Bézier spline. 1 point, 2, 3, 4, 5, 6 points, degree 5. When I select it, you can see it says degree 5 right here. I can raise it to degree 6 or degree 7. The higher the degree, the more points I get. And that gives us much more freedom to shape the spline exactly how we want. But if I lower the degree from 5 to 4, watch, one of the curvatures disappears right away, as you can see now. So now it's degree 4. That means a maximum of 3 inflection points. 1, 2, 3. Drop it to degree 3 and we lose another inflection point. Drop it to degree 2. Now we're down to just 1 curve change. Okay, I'll delete this so we can bring the reference image into SolidWorks. To bring the image into the sketch, I first enter a sketch on the front plane. Then go to Tools, Sketch Tools, Sketch Picture. We'll cover Sketch Picture in detail later in the session where we design directly from photos. For now, I'm just importing the image using the method I showed you. Using these parameters, I can move, rotate, or resize the image. So with these settings, I click OK. Then I go back to Tools, Sketch Tools, Sketch Picture, and import the image again. This time I move the second image to the left by the exact amount of its width, matching this dimension. So here, I type negative 837 millimeters. All right. Now we trace the lines on these images using both the Spline and Style Spline tools. So first, I trace the shape using the regular Spline tool. This way, I'm tracing the curve so it perfectly matches the line in the reference image I prepared earlier. Okay, now let's draw the same line again using the Style Spline tool. I see 3 distinct curves, this one, and this one. 3 inflection points mean we need a degree 4 Bézier. That requires 5 control points. So I select Style Spline. 1 point here, 2 here, 3, 4, and 5. And with these control points, I match the shape exactly. If you noticed, with the regular spline tool, we move the spline's points themselves. With Style Spline, the points stay fixed. We move the control points instead to shape the curve. So, using these control points, I shape the curve to match the reference exactly. Now, what's the difference between the two? When should we use the regular spline and when is Style Spline the better choice? If you right-click the spline and choose Show Curvature Combs, it instantly shows the curve's smoothness and radius of curvature. Let me increase the scale a bit so it's easier to see. Same thing for the Style Spline. Right-click and select Show Curvature Combs. As you can see, the Style Spline gives much smoother and softer curvature changes along the curve. But not here. Look at these sudden spikes in the regular spline. And that's exactly why the Style Spline is so much smoother. It's drawn using proper Bézier control points. But here it was drawn with standard spline tool. The curvature changes lose their smoothness and don't stay as clean and orderly as they do with Style Spline. I can increase the degree of the Bézier curve as much as I want. Let's turn off the curvature combs. If the Bézier degree drops below 4, we had the curvature like this. There, one inflection point is gone. Lower it again. Another inflection disappears. Keep going and it eventually becomes a straight line. So here we clearly see the difference between the two spline tools. Let's go back and draw this shape again using the regular spline tool. Of course, the more time you spend, the more accurately you can trace this shape. Like this. And then I draw the same shape using the Style Spline tool. Like this. It just takes a little practice to get comfortable with the tool. If you need more control in a specific area, simply increase the degree. You'll instantly get more handles and can shape the spline exactly the way you want. But keep this in mind. According to the video we watched, every 3 control points create 2 handle segments, and the curve between them is shaped. Okay, back to here. I increase the degree to get more control over the spline. All right, I draw it like this. Now I turn the curvature combs back on. I lower the scale a bit. Curvature combs are crucial for achieving high-quality surface finishes, ensuring smooth transitions for product design. The differences are clear again. So in this exercise, we learned how Bézier curves work, saw the real difference between regular spline and style spline, and successfully traced a hand-drawn line in SolidWorks using both tools.